that this is the same as our classifying polynomial sheet. Guys, but what questions from this do we have? Want to see? Want to go over general, specific? Any questions, confusion? Now is the time to ask.
Actually, I have a question about the quiz.
Okay.
Is it gonna have like the tables on it?
So no, it will have a word bank, but it won't specify are these the degree or are these the number of terms. So you'll need to know which are which.
Okay.
Yes. It will not say that.
We're working together.
If no questions from this page, go on to the next. Yes. Yes. We'll do the last one on the first page and then move on. So in order to put this in standard form, ABC order first, and then highest exponent. Also remember that polynomials is the umbrella term for all of these things, and it means something specific. So keep those both in mind. So ABC order first and highest exponent, negative x to the third. Then anything that has an x, negative 7x squared y squared. Then the next exponent, because we don't have, the next variable, because we don't have any more x's. Y to the third, 5y to the third, and then our constant 13. Number of terms, this would be a polynomial, specifically using the term, not the umbrella term. And then degree for this one would be weird, but you wouldn't get a degree question with a combined thing like this. But it would be 4 because of this one. Yes. Yes. So 6 is just classifying. It's already in standard form. ABC order, there's only one variable and highest exponent. So this would be a degree of 4, which is your quintic. Quintic is 5. And it has 4 terms, so polynomial.
To find out the degree, just count them.
You look at the highest exponent. Number of terms is how many things you see. Okay, on to page 2. Questions there? So the speed of sound in water is 1.46 times 10 to the third meters per second. The speed of sound in air is 3.31 times 10 to the second power meters per second. How much faster does sound travel in water than in air? So because we're looking for how much faster, we're going to subtract one from the other. In air minus water, I think it's that one. I could be wrong. I could be good. I think it's the other way around, but we'll try this one and then the other one. But when you're subtracting, you have to make the exponents the same, so you have to figure out which one you want to change, the first or the second. So do we want to change the first or the second? You guys should
Change the first.
first, okay. So then in order to change the first to an exponent of 3, we would be moving this exponent up, which means we added, which means we're going to move the decimal place to the left. I did it the wrong way, yeah. I switched them. It should have been the other way around, but if we had subtracted, we wouldn't have gotten a positive number. So then if you go ahead and subtract those, which of these answers would you do? Because of the exponent. So B was close, but the exponent wouldn't have been correct. Other questions there? On that page. Okay, go on page 3. I'm just going to fill out these at the top. These are the rules that we talked about already. We just didn't name them as product, power, quotient. If we are multiplying like bases together, what are we doing with the exponents? Adding. If we are raising a power to another power, what are we doing with the exponents? Multiplying. And if we are dividing like bases, what are we doing with the exponents? Subtracting. The negative exponent rule, if you have a negative exponent, take the base, flip it, and make the exponent positive. If you want to put your 0 exponent rule, anything to the 0 except your special cases, equals 1. Right. Questions on this page? 14 and 16. 5, 12, 12. Okay. So for this one, we are 11. We're dividing like bases, so subtract the exponents. You have a to the first, b to the third, c to the 0, and anything to the 0 is 1. So that would just become 1 and disappear, and we just have a, b to the third.
Where do we get the A and B to the third from?
A to the first is the same thing as A, and B to the third. 12, we have a power to a power, and we're multiplying like bases, so you could do them at the same time. Multiply all of your exponents. So this would be negative 3 in parentheses squared, x to the 12, over, actually multiply the numbers, 15, add the exponents. Negative 3 squared would give us positive 9. Then we are dividing like bases, so subtract the exponents and simplify or divide 9 by 15. So if we simplify that and subtract, we have 3x to the 6 over 5. Or you could write it as 3 to the 5th, x times x to the 6, and then condense it. Questions so far on those two? We are multiplying and dividing, so let's deal with the numerator first. Multiply your actual numbers. Add, or in this case, subtract the negatives. So negative 3 minus 2, b to the negative 5. Actually divide the numbers, or simplify them, and subtract your exponents. 21 over 6 would be 2. I'm going to write this separate. If I'm subtracting this would give me b to the negative 7, and I'd have to take that and flip it. It would be 7 over 2b to the 7. And 16 is similar to 12, but in reverse. So we have to deal with these exponents first. So a to the 12, b to the negative 3 over, multiply all of your exponents, a to the negative 4, b to the negative 4. Then subtract your exponents. 12 minus a negative 4 would be 16. Negative 3 minus a negative 4 would be 1. Or you can just write it like this. Yes.
Why is it 16?
What's 12 minus a negative 4?
Why is it? Oh. Never mind.
Other questions there?
So it can be a non-calculator section.
Not for this one. On to page 4. Questions here?
We do 21 and 19.
I'm going to say 21 is very similar to the one we just did, but we can still do it. 21 and 19. So,
Yeah.
for 19, you have to deal with the exponent. I'm going to just rewrite this above this just so you can see what each thing says. So we would take the exponent on the outside, multiply it to all the exponents on the inside. So that would be negative 2 to the third, a to the sixth, b to the third. Figure out what negative 2 to the third is. Negative 8. And we're going to multiply the numbers and add the exponents. So we have negative 40, a to the 7th, b to the 4th, which is b. Deal with the exponents in the denominator. Again, I'll rewrite it. So we have x to the 5th, y to the y squared, z to the 8th over x to the negative 3, y to the negative 3. And then you can either subtract as is or flip the x and y up and deal with it that way. It doesn't matter. If I'm just subtracting 5 minus negative 3 would be x to the 8th. 2 minus negative 3 would be y to the 5th. And z doesn't have a like this. Like, yeah. So d. Other questions on this page?
I'm not doing this one.
Yes. Yes. So as long as you remember the area of a rectangle is length times width, perimeter you're adding up all the sides. This is all of your polynomial operations. Perimeter first, remember that this is the same on the opposite side. So you can use 2 times the length plus 2 times the width, or you can just add up all the sides, it doesn't matter. For space purposes, I'll do 2 times 13x plus 2 times 4x squared y. And then just multiply both by 2. Here you're only multiplying to the coefficients. Exponents don't change. But this is not standard form, so I'm going to rewrite it. Oh, that should have been 26, not 13. For area, we are multiplying the 2. So that would be area equals 13x times 4x squared y. Multiply the actual numbers was 13 times 4. Someone do that math or do it in your calculator. We're multiplying these, so the exponent for x is going to change to 3, and the y just stays the same. If you got something like 28, I would give you the area. If you wanted to practice this at a later time. This is 1/2 times base 1 plus base 2. It doesn't matter which one you call base 1 and base 2, and then times the height. So again, just combining the terms and multiplying. Any other questions on this page? Skip over 5, go on to page 6. And there are some repeat questions up there. Questions on this page? This is that same area formula. So we have 1/2 times, let's call this base 1, 3mn cubed plus 9mn cubed times the height 5n squared. So inside the parentheses, you have the same exponents and variables. You're just combining the terms. The exponents wouldn't change inside the parentheses. But when you multiply everything, that's when your exponents would change. So 1/2 times 12 is 6. 6 times 5 is 30. There's no other m's. And if I multiply these two, I'm adding the exponents. So 30mn to the 5th d. Other questions on this page? Page 7 is a complete repeat of page 3, so skip that page. Questions on page 8. Ignore 11 and 12. We are multiplying this term to all the terms here. We're multiplying and adding the exponents, actually multiplying the numbers. So 5c squared d times 9c squared d squared would be 45. C to the 4th, d to the 3rd. Add your exponents, multiply the numbers. Then the next term, negative 20, c to the 5th, d squared. And the last term, negative 10, c squared d. And none of these can be combined because none of them are like terms. Yes. 10, use one of your methods of multiplying. So do we want to use box, FOIL, double distributive? FOIL, okay. So x times 5x would be 5x squared. X times negative 2 is is what?
Negative
Negative 2x. 4 times 5x. 20x. And then 4 times negative 2. Negative 8. Keep bringing down that negative 2x squared. Combine like terms. I forgot x. And then over. We have 3x squared plus 18x minus 8. When you get things that have two sets of parentheses, binomials times binomials, make sure you are multiplying everything together, not just two things. Other questions on the stage? Or the last page? First, outer, inner, last. The first terms of both sets of parentheses, the outside terms of both, the inside terms, and the last terms. Yes. The first terms, the outside terms, the inside terms, and the last terms. Remember, you can also use the box method. You can also double distribute. The first term times everything here, plus this term times everything here. Either way. Okay, go ahead and clear off your desk except for your SOL packet. Leave that out. I'm also going to be handing out something else that I will talk about towards the end of class. And we'll go over the SOL packet towards the end of class. Unless we don't have time, then we'll go over it Friday.